Another powerful feature of Symfony is the integrated caching. So let's take a look at how we can take our leap year page and add caching to it so that it only produces an answer every so often. This isn't super useful for a calculator where we're going to get a different value every time, but it will serve as a good example of how the caching works and how we can simplify the caching by using HTTP kernel instead of our custom framework code. And we'll get to that in just a minute. Okay, let's jump to our resource pack directory and let's open up the 58th step, which is called front.php added caching. I'm going to copy this code and paste it over the code in my front.php file and save it. So this is half of the process, and we'll talk about the code in just a second here. But let's finish this by updating our framework.php code as well. So we'll open up step 59, framework.php, adding caching support, and we'll copy this code and paste it over the code in framework.php and save it. Okay, now let's compare our two front.php files, this version and the version before, and we'll do the same thing with framework.php. First, front.php. So I'll compare step 58 with step 55, and I'll take it over to my file comparison tool. So the one thing we're adding here, besides our use statements here, is a wrapper around our framework object. So instead of just using framework handle, what we're doing instead is wrapping framework inside of this HTTP cache object. And you see that we have that set here to use the namespace. We pass it our framework, and we set a new store for it. And here's our use keyword for our store namespace. And we specify a location where we're going to store the files. So this cache that we create is being stored in files. And so instead of processing all of our framework code, if we have a cache file that already exists, we're going to use that file instead, which will save us on processing power. With our simple application right now, it's not a big deal. But as we get more complicated and the processes that occur on each page take up a good bit of our resources, using caching makes a lot more sense. Chances are, if you've been working with Drupal for a while, you've already harnessed the power of caching in order to turn on caching for anonymous users or to cache particular views or particular blocks. And you can do the same thing with Symfony. Caching individual parts of pages requires more configuration with the use of edge-side includes, but because it requires a particular configuration on your server, we're not going to go through that process in this series. So what this does is just create a cache of our entire page. Finally, we use handle in order to grab the response from our framework, but this time our framework is using HTTP cache. And so first it will check the cache to see if a response exists for this particular route. If it does, it will return that. If not, it's going to create it using our original framework object. And finally, we'll send the response. Now, in order to support this, we have to adjust our framework code a little bit too. So let's compare our step 59, framework.php, with step 47. I'm going to drag these over to the file comparison tool. So here, our framework now implements HTTP kernel interface. This is going to enable us to support the caching. If we look at our handle request here, instead of just taking the request parameter, we're taking an additional two parameters. Type equals HTTP kernel interface, : master request. You're probably familiar with the structure by now. The double colons mean static, and in this case, we're not accessing a static method. We're instead accessing a constant within this class. This final parameter is catch equals true, which is saying that we're going to catch errors. All right, and besides that, nothing else has changed. In order to test this out, we need to set a time to live inside of one of our controllers. So let's do that with our leap year controller. I'm going to go back to our resource pack directory, and I'm going to open up step 60, which is leap year controller.php, adding caching for 10 seconds. We'll copy this code and we'll paste it over the leap year controller. If you don't have it open, go ahead and jump over to your examples and open up leap year controller.php. Let's copy over the code and save it. So we've made a couple changes here. Let's jump back to our resource pack and compare this with our previous leap year controller.php. It's step 35. We'll compare this in our comparison tool. So in our first case, what we did was return a new response if it was a leap year that says, yep, this is a leap year. And if not, we returned a response that said, nope, this is not a leap year. In this case, we want to wrap that response creation in an if-then statement, so then we can set the response's time to live. Time to live is just a phrase for how long a particular file is supposed to exist in a cache before it gets refreshed. We're also adding a random number to the output of our response so that we can tell if that number changes with each page refresh. And after we set up our response, we're going to use the set TTL, time to live, to 10 seconds. So the set TTL method of our response is what allows us to tap into our caching mechanism now for a particular controller. If we didn't set this, there wouldn't be any caching at all. So we can control this granularly from page to page. Okay, now that we have our front controller set up, our framework set up, and our controller set up, we should be able to test this out. So let's jump back to the browser and I'm going to refresh. And notice the code right here. If we refresh and keep refreshing, we're not going to see a change until 10 seconds in. So I'm refreshing, you can kind of see it up here. And then if we do it now, we have a different number. Okay, so it looks like our caching is working properly. We're also seeing this GA code from the subscriber that we added in our last steps.